Hello students, Ms. Slyman here with our next set of notes. So looking at finally the graphs of rational functions. So the key here with rational functions is that they always have this sort of problem area. So we know straight away from looking at this that x is not allowed to equal 3. That means I'm going to have an asymptote. So this here, this line, we call an asymptote. A-S-Y-M-P-T-O-T-E. And this is a line that my graph approaches, but it never crosses a vertical asymptote. We're never going to be equal to it because if my x was allowed to be 3, I'd divide by 0. So let's look at some points on either side and try and see what's happening. If I plug in 0, I'll have 0 divided by -3, which of course is just 0. So I go through the point 0, 0. If I look at 1, I'll have 1 over -2. So that gives me 1 and -1/2. If I plug in 2, I'll have 2 over -1. So that's -2. If I plug in 2.5, so let's come here. So 2 divided by 2.5 minus 3 is going to be -0.5. So that's going to give me -4. And the closer that I get to this 3, I'm always going to have a decimal because I'm always going to be putting in numbers less than 3, and that decimal is always going to be negative. But dividing by a decimal makes a number bigger and bigger. So I'm going to be heading towards -infinity down on this side. Thinking about what's happening on the right-hand side, if I plug in -1, I would have -1 over -4, so that's -1/4. If I plug in -2 over -5 is -0.4, so that's a little bit bigger. -3 over -6 is -0.5, a little bit bigger. Let's pick one further down. Let's go to 8. -8 over -11. Well, that's bigger, but still less than 1. I'm always going to end up less than 1. If I pick 100, I'll have a -100 over -103. So I'm going to be getting closer and closer to 1, but never actually hitting it. That's another asymptote. So this graph is going to be coming up towards 1, but never reaching it. And there we go. So that's on the left of 3. Now let's think about what happens on the right of 3. So if I think of numbers between 3 and 4, so if we started with like 3.1. So now we're thinking on the right-hand side, right of x equals 3. So 3.1, I would get 3.1 divided by 0.1. So that's a positive number, but again, I've taken a number and divided it by a small decimal, makes a very big number. So let's look here. 3.1 divided by 0.1 is going to give me 31. So I'm starting up very high and very positive, but then as soon as I hit 4, now I'm going to have 4 divided by 1, which would be +4. If I think about 5, I would have 5 divided by 2, that's 2.5. If I had 6 divided by 3 is 2. So again, let's think about getting bigger. If I look at 10 divided by 7 is 1 point something. 100 divided by 97 is bigger than 1, but just barely. 1,000 divided by 997 is bigger than 1, but again, just barely. So now on this right-hand side, I'm coming from +infinity and heading down towards +1. So thinking about what's happening here, I can talk about as x approaches 3, what's happening, and as x approaches +infinity or -infinity. So let's sum that up. I'm going to type this out. So as x approaches, let's start with negative infinity. Then the graph approaches y equals 1 from below. So we're coming up from below and approaching 1. The opposite side, as x approaches positive infinity, our graph approaches y equals 1 from above. So we were getting closer and closer, but always our numbers were bigger than 1. So 1,000 divided by 97, 100 divided by, sorry, this should have been 997. These numbers are close to 1, but bigger than 1. Our other key areas to think about were as we approach 3. So as we approach x equals 3 from the left, the graph went to negative infinity, negative infinity, and vice versa. So that means the opposite. As we approached x equals 3 from the right, our graph went towards positive infinity. Again, that's because as we got closer and closer to 3, we were dividing by decimals. And as we were dividing by decimals, we were either making big positive numbers or big negative numbers. So that's what we want to think about with these graphs. We want to think about our key point, so where we're making asymptotes, and what's happening to the graph as we approach that key point. Also, what's happening to the graph as x approaches infinity and negative infinity. So let's look at a second example in example 2. But I'm going to stop here with example 1.